Hello everyone, my name is Krishna Kaushik and this is our team Unveiled HOC and we are presenting you with our product PSX. We are creating an agentic industrial digital twin platform. It is designed to rethink how future industrial control systems should operate. Modern factories generate enormous amounts of alarms, telemetry data, maintenance notifications, and operational sensor data. Traditional HMI and SCADA systems force operators to manually interpret this information using rigid dashboards that are overloaded and difficult to adapt. This creates an operator cognitive overload, an alarm fatigue, delayed responses. So instead of building another monitoring dashboard, we asked, what if industrial software behaved like an intelligent operating system? That became PSX, a platform combining of AI-assisted industrial reasoning, adaptive role-based interfaces, metadata-driven low-code HMI, studio displays, and a hyper-realistic industrial digital twin. Our goal was not just visualization. Our goal was to create a system that understands operational context, prioritizes information intelligence, and transforms raw telemetry data into actionable industrial intelligence.
Hello, judges. My name is Triti. One of the biggest challenges in industrial software is scalability. Whenever a new machine or telemetry signal is added, traditional SCADA systems require manual dashboard redesign and extra front end work. To solve this, we built a metadata driven low code architecture in PSX. Our platform dynamically generates interfaces using reusable templates, centralized schema registers, and configuration driven rendering. Instead of hard coding every telemetry panel, the system automatically creates interfaces based on machine configuration, telemetry type, and user role. This reduces engineering effort, deployment complexity, and maintenance cost. For example, operators get safety focused dashboards, engineers get detailed diagnostics, and managers get predictive analytics. With this approach, industrial HMIs become adaptive, scalable, and context aware systems. Thank you.
Hello, judges. At the core of PSX, the UX is designed around one powerful idea. Industrial software should adapt to the user, not force every user to adapt to the software. So, here traditional industrial HMIs and SCADA systems usually display the same complex dashboards to everyone. But in real factory environments, different users need different information priorities. An operator on the production floor needs critical alerts, machine safety, simplified health metrics, and fast decision visibility. An engineer needs deep diagnostics, vibration telemetry, FFT analysis, and root cause investigation tools. A manager needs predictive maintenance insights, downtime forecasting, operational analytics, and business level visibility. So instead of building a static interface, we designed PSX as a role adaptive industrial interface system. The platform dynamically changes telemetry density, interface complexity, visual hierarchy, and diagnostic depth. Based on the active user role, operational context, and machine conditions, this creates a far more intelligent and human centered industrial experience. Coming to why this matters, in industrial environments, information overload can directly impact response time, maintenance efficiency, and downtime costs. Our UX system helps users focus only on what matters most to them at that moment instead of overwhelming users with raw telemetry. PSX transforms industrial monitoring into an intelligent, adaptive operational experience.
The core intelligence of PSX comes from our agentic AI workflow architecture. Traditional HMIs only display alarms. Our system goes beyond monitoring by simulating how intelligent industrial agents reason through failures. For example, instead of showing high vibration is detected, PSX performs contextual reasoning, such as identifying vibration anomalies, correlating thermal drift, detecting bearing degradation, estimating maintenance urgency, and predicting operational risk. Inside the command center, our fault investigation workflow demonstrates explainable AI reasoning. The system explains why a fault is occurring, what component might be affected, estimated downtime, and a confidence score, and maintenance recommendations. We also developed an agent orchestration interface visualizing how industrial agents collaborate like telemetry agent, diagnostic agent, maintenance agent, and planning agents. This transforms industrial software from a passive monitoring into intelligent operational assistant. Even though the backend AI is architecturally very strong, that needs to be changed into working for an Raspberry Pi or an Arduino based systems. Because what we are trying to do is to make this AI run on AI edge devices. And edge AI is what we are trying to achieve over here. We can make sure that very small hardware requirements will actually feed with our HWI surfaces, and it just works perfectly well.
Hi everyone, I'm Abhinandan. I'm here to present about PSX command flows and predictive maintenance workflows. The core operational of PSX is the command center. This is where the telemetry, diagnostic, predictive maintenance, and all intelligent workflows come together. The command center integrates telemetry cards, FFT spectrums, anomaly system, maintaining recommendations, and root cause investigation flows. Instead of simply generating alerts, the platform simulates anomaly work detections, maintaining timeless confidence scoring and predictive diagnostic. For example, the system can identify outer race bearing, hmm, lubricants instability, thermal anomalies, shaft imbalance, and vibration irregularities. We also implemented animated investigating steppers, contextual telemetry drill downs, and intelligent fault prioritizing systems. The main goal was to make industrial telemetry understandable instead of overwhelming. This creates a far more operational use, which is really helpful for industrial monitoring environment. Thank you.
Warm greetings to the respected judges. I'm Neha Thakur. In real industries, engineers cannot directly test operational changes on expensive machinery because issues like overheating, voltage fluctuations, vibration imbalance, excessive current draw, or incorrect RPM variation can damage motors and interrupt production. So instead of experimenting on physical equipment, PSX allows engineers to safely validate machine behavior inside a virtual digital twin environment. We also simulate how changes in motor load affect parameters such as current consumption, heat generation, rotational stability, and operational efficiency. For example, when cooling efficiency decreases, thermal rise inside the motor increases, which affects winding insulation, bearing stress, rotor balance, and long-term machine reliability. Similarly, FFT spectrum analysis helps identify resonance frequencies, imbalance patterns, and bearing race defects before physical failure occurs. This allows engineers to safely inject faults, simulate operational stress, analyze machine response, and study predictive maintenance conditions without risking actual industrial equipment. Thank you.
The most technical, intensive component of PSX is our industrial digital twin system. Instead of importing pre built assets, we procedurally generated industrial motors using raw 3JS and WebGL because running on edge devices and running on small devices is literally what we want. Each motor is built parametrically using geometrical logic like cooling fins, bowls, rotor systems, cable routing, shafts, and ventilation structures. And the thing is, this can be procedurally generated for any kind of content. Let that be a big generator, let that be a big motor, or any industrial scale hardware product can be connected to our Raspberry Pi or anything, and then we can configure our own 3D model for our industrial digital twin system. The digital twin supports real time interaction and full screen kiosk visualization, motor switching, RPM manipulation, and fault injections. Because this is what we want. If our AI suggests some changes to improve the efficiency or and generates a report, we do not want to try this on hardware, on our expensive hardware. Instead, you can try it and visualize in our digital twin experience, and then we will know what to have this final conclusion. PSX is our vision for the future of industrial intelligence, a future where AI explains operational decisions, interfaces adapt automatically, and digital twins become intelligent engineering systems. PSX is not just a dashboard, it is a next generational industrial operating system. Thank you.